Welcome to part 2, volumes by cross sections. So to go a little bit more in detail about it and how we can apply cross sections to find the volume, we're going to just remember one formula. The volume of any rectangular solid, or any solid in general, is going to be the area of the base times the height. Now, in terms of x, we get to keep everything in terms of x. So they say let the area of the base be a of x. So to get the volume, we're going to say that's a of x times the height. Now the height in this case is going to be dx, because remember they're going to be very thin. So if I have like this little slice right here, the area of the base in this case is a circle. The height of that is dx. It's very thin. In that case, it's actually going to be dy, but we'll talk more about that later on. So if it's in terms of the y-axis, perpendicular to the y-axis, the same thing, except we're going to use a of y. There's the area of the base times dy. So we're going to take a look at how we can solve these. We have a solid. Let's say it's bounded by the circle x squared plus y squared equals 9. Now I want to find the volume. So once I know its volume, I know it's going to be area of the base times the height. That's what volume is. So I need to get the area of the base first. So that's what we're going to find. To find the area of the base, we're going to draw our circle. 3, it has a radius of 3, and I draw my circle because it's all about that base. No trouble. Now, I am in terms of x, so if you remember, if we're in terms of x, that means we are going to have a vertical rectangle. So I draw a vertical rectangle, top to bottom. And I draw that over here. It's dx thick because it's vertical, and I need to find the height of that rectangle. So to do that, remember we're going to take the top function minus the bottom function. And in this case right here is the difference of two circles, two semicircles. The top semicircle, if I solve, is going to be y equals the square root of 9 minus x squared, where the bottom is going to be negative square root of 9 minus x squared. And remember, we get that when we solve this equation, right? We would get y equals plus or minus the square root of 9x squared. So my equation is going to be the top function, which is 9 minus x squared, minus the bottom function, negative 9 minus x squared. So that's going to give me 2 times the square root of 9 minus x squared. And there's my base. So I got the area of my base right here. Once I get my base, I'm going to look at the square. Well, sorry, get the area of total. We're going to take this 2 times the square root of 9 minus x squared times dx. And that, is actually the area of the base. Once we get this, now we're going to try to get the volume. Well, that's just the very flat part. That's just the very bottom. In this case right here, we're going to have squares. So here's kind of a square. So what that means is I'm going to have a cross section that's in the shape of a square, which means I'm going to draw a square now. At the very bottom of my square is my base, which we know is 2 times the square root of 9 minus x squared. That bottom part down here, that's my base, which we found right here. We're just putting it on the bottom. So it goes from here to here. Very simple. It is a square, so I know that the height's also going to be 9 minus x squared. And I'm adding a little bit of thickness to it because remember, it is dx thick. That's where we get that dx from. And I just find the volume of this. It's a square, so the volume of a square is s squared times the height. Area, take a look here. Area of the base times the height. So if I find my volume here, very simple. It's just my side squared. 2 times the square root of 9 minus x squared. And the height here is dx. Really, really that's the area of my base, but the height is 2 times square root of 9 minus x squared, but we can write them in any order. Now that's the volume of one square. I will simplify it a little bit, and we get 4 times 9 minus x squared times dx. And remember, this is the area for one rectangle. One square. to get them for all the squares, we're going to integrate from -3 to 3. So I take the antiderivative, notice I put the 4 on the outside because it's a constant, from -3 to 3. And that's how we get the volume. And you can type that in your calculator to get the answer. Okay, I think it's 36 units cubed. Okay, so the next one we'll take a look at is our equilateral triangle. Now the volume formula for an equilateral, so I'm going to now draw an equilateral triangle. So remember, this is a square, and we talked about that. If it's a square, it's going to give us a shape. The next we're talking about triangle. So now my same base, the same bottom, but now my height is going to be done by triangles. So I'm going to draw an equilateral triangle. Now we talked about this in part 1. If we do triangles, my cross sections are triangles, like so. What do we get? A cone. So this is going to generate a cone for us. There's my base. It's still 2 times 9 minus x squared. Now, to get the area of an equilateral triangle, I'm just going to go ahead and give that to you. It's s squared times the square root of 3 over 4. So there's my side. So to get the volume, remember, it's area of the base times the height. Well, we just got the area. That's this. So to get my volume, it's going to be s squared root 3 over 4. And this h, that's going to be our dx. So once you get the area of the base up here, all you have to do is get a formula for a square, formula for an equilateral triangle, and just plug your side in there. This becomes v equals s squared, so I get 2 square root of 9 minus x squared root 3 over 4 dx. It's ugly, but it simplifies pretty nicely. 2 squared is 4 over 4 cancels, so I'm left with the square root of 3 times 9 minus x squared dx. Now this is going to give me the volume for one triangle. That's the volume for one equilateral triangle. Dx thin. It's a volume. You may say, there's no area, it's a flat surface. But remember, it's super thin. Look how thin that is. Dx thin. Thin. Thin to win. It has a volume. Take a look there. Take a look. It has a volume. It's very thin right there. It's essentially 0, but it does have a volume. So we integrate to get the rest of them from -3 to 3. And you just plug that in your calculator or solve it by hand, either way. So let's take a look at the next shape. What if we have an isosceles right triangle? Now for an isosceles right triangle, same idea, it's going to give us another cone, an isosceles right triangle cone, which is not an isosceles triangle cone, whatever, right? So if I draw that, there's my isosceles right triangle, right angle on the top. There's the base. It's all about that base. There it is. It's no trouble. So what we're going to do now is I want to find the volume for this. But I need an area for them. Because remember, volume is the area of the base times the height. So I need the area. Well, how do you find the area of an isosceles right triangle? There's an app for that. It's 1/4 s squared. That's the area formula right there. Very simple. You can prove that easily by just dropping an altitude right here. This is s over 2. That's s over 2. So we know it's going to be squared, so it's 1/2 s over 2 times s, the whole base. So you can verify that if you need to. Come by if you need help on that, okay? Now, so to get my volume, my rule says, take my base, that area I just found, 1/4 s, which is my side, 2 times 9 minus x squared, multiplied by dx. Because that's dx, the height. And I simplify that. This cancels. I'm just left with, wow, 9 minus x squared dx. And then to integrate that, we're going to go from -3 to 3. Now in the AP test, here's how they're going to ask it. Yesterday we said find the area between two curves. That's here. I would just integrate here. Today it's asking us to find the volume, so we just find the volume formula and use that same base. Very easy to do. Okay, so take a look at a bunch of these. Okay, I'm just going to stop right here, but I will be available for tutorials. Just feel free to ask me questions. Okay, bye bye.